Hi, everybody. Thank you for joining us at the inaugural lecture series for Woodbury Computer Science and Media Arts Department. I'm excited. I hope you're excited too. We'll be talking about the role that technology is playing in shaping like music production, music creation, composition. Hopefully talk about all of those things. So I'm going to do a quick introduction for our first speaker. So thank you, Raul and Martin, for joining us this evening. So our first speaker is a creative engineer who specializes in audio systems. He is trained as an audio engineer, a musician, and is a self-taught software developer currently working in immersive media. Please help me introduce Martin Rivera. Woo! So Martin, take it away.
Thank you. Thank you very much, Kako. It's really a great pleasure to be here with you, talking about some of the stuff that I do. I love to share some of the ideas and some of the things we're working on. I'm also really honored to be with Raul Feliz also, and I'll begin a little presentation to share my screen with you all, so we can begin, right? I'll be going to. Okay, awesome. So you guys can see my screen?
Yes,
yep,
I can see. Yeah.
Awesome. Okay, just double checking. Well, I'm really interested in talking about this idea of the overlap between creativity and technology. Kako just introduced me as a creative engineer. And when I talk about the stuff that I do, the stuff that I worked on, I talk about it as creative engineering. And of course, every engineering is by definition creative. But the idea is that the way I think about it is that I apply engineering knowledge and design into the arts, into visual arts, into music, and more recently in immersive media and immersive experiences. I have the honor of being a collaborator with the Mexican studio Cocolab since 2019. And some of the examples that I will be sharing with you will be from projects within Cocolab. And this is the first example. As I said, I'll be using several examples, and I will try to make emphasis in the ideas that permeate arts and creativity and engineering and technology. So this first slide is a picture of a project we made in 2021. It's an immersive installation, an immersive experience based on the life and work of Mexican artist Frida Kahlo. This is Frida Inmersiva. And this is the sort of projects that we are involved in. We can see these large spaces with projection mapping, light design, multi-channel audio, and we try to use all these tools as vehicles for telling some stories, right? This is the big idea. I want to share with you a little video so you can see what it's like to be inside of one of these experiences. This is precisely the one on Frida Kahlo. We had this story around her life. We had her voice in voiceovers of actresses. We had these little interactive games where you can paint in a digital canvas. So this is just to give you a little bit of an idea of the kind of projects that we are involved. I'll be talking a little bit in depth about some of the aspects of these ones. And this is another example. Another class or type of projects that we are involved is in archaeological sites around Mexico. And this, I think, is a beautiful project that we were involved in the south of Mexico. Is in the archaeological site of Uxmal near Mérida in Mexico. So the idea with this one is that we have these amazing archaeological buildings and that are very important for the Maya culture in Mexico. And we were lucky enough to uh, tell the stories of the Maya culture in the walls, in the pyramids, in the actual site of like this millenary culture. So this particular experience was it is still a night walk. You can go through the archaeological site at night. You can go through different parts of this big archaeological zone. We arrive at this square, these buildings that we used to tell the story of. Well, it's a traditional tale and of the birth of this culture. And once again, we are using this idea of interactive media, immersive lighting, like big pads where you hear sound, this multi-channel experience when you arrive to a final show, right? So these are a few examples of what we do. And me, I am part of the audio team in Cocolab, and we call ourselves the ear people. Cocolab is a multidisciplinary studio, so we have animators, we have set designers, we have research people that do the research and the history and whatnot. So we are the audio team, right? This is the core of the team. The team has been steadily growing, but this team is led by Eddie Kisler and Eugene Toali. Eddie is an amazing musician and music producer from Mexico, and Gene is an incredible producer and audio engineer, also a musician from uh, raised in Brooklyn. He worked in California and now is working with us in Mexico City. And Lorena, she's our coordinator and audio engineer, awesome audio engineer. And here we are working on site on the Frida experience, like during the production part of this project. So we are the ear people, right? And one way of talking about what we do, the projects that we do, I think it's very useful to frame it with this publication. It's called Future Art Ecosystems. It's created by this group, Serpentine Research and Development. And this is a text that talks about these sort of groups like Cocolab that are using new technologies to tell stories, like to create these experiences and to build, like I could describe it as new media, right? But one of the ideas that I really like to use in this context is the idea of an art stack. An art stack is one of these organizations that uses technologies and develops new technologies in order to create works of art, right? So a little like really quick recap of this idea of the art stack would be that it's an organization that is artist led. First of all, it has a lot of in-house functions like creators and artists, curators, software developers, and technical designers, also graphic designers, all this stuff. And the idea is that the support, like the technologies, like talking about again about video mapping and multi-channel systems, is to have a little bit of a do-it-yourself approach to tech. I believe that this do-it-yourself approach also includes comparing tools, right? I'm going to talk a lot about that in this talk, comparing tools like using these platforms, these technology or development platforms like Touch Designer or MaxMSP, and integrating with other solutions like other off-the-shelf solutions. Let's say. So I like this quote. It's like you're a painter, but you also have to invent paint. It's a little bit of the idea of the art stack and the kind of projects that we do. So this is another example of the Frida immersive experience. This is one of the centerpiece of the experience. It's a beautiful light sculpture. And we nicknamed this part of the installation as Frida's heart, right? And this is behind the scenes. This is actually Frida's brain. No, this is the video servers, the operation nest, all the networking cable that goes around. So for me, it's an analogy to this balance between art and technology. So we develop all this technology. We build these systems for these experiences, and that was like very interesting for us, right? So it's going around is this idea of technology and art in a single group of people, right? And I myself, as in more of a technical, more of a technology position, I gather a lot of information, and I get a lot of inspiration from the people that develop software, that create technologies, and that's where I found this quote. Right? I do believe that technology brings benefit when it diminishes a limitation. So a limitation for us would be, where can we tell a story? So the technology of video mapping and video projectors and lighting allowed us to tell a story, for example, in archaeological sites of Uxmal, right? And at the same time, we are developing creative processes. So I think I like to contrast a lot this quote with the former one, and it goes like this: whatever diminishes constraint diminishes strength. The more constraints one imposes, the more one frees oneself of the chain that shackles the spirit, right? So it seems to be a little bit of a contradiction. We have limitations on one side, and we have constraints on the other. So it's beyond like a synonym or beyond language. I think it sheds light on the idea of this interaction between technology and creativity, right? The idea of limits or limitants, and the idea of constraints on the. So this is a little example of another project that we made. This is a smaller project, a smaller immersive experience for a brand here in Mexico. And one way to approach this project for us was to make a few custom tools, right? We figured out that it would be really interesting for the music content to have this sound design that is, completely specialized. So we had, if I remember correctly, we had 6 front channels and 2 back channels. So in order to make this experience immersive in the audio part. So for this, I developed a little tool that allowed us to make traces, to think about these chaotic patterns that these butterflies make when they are swarming around you. And the main idea here is that it helped us scale this content. We have these sound recordings, these Foley recordings, and we try to make a tool that allowed us easily to specialize. So some of the tools we make for ourselves are a little bit, the user interface a little bit cruder, because in the end, I am the final user for this kind of tools. But it's really interesting to have access to be able to, like, just for the necessities, the creative necessities of these projects, right? And sometimes we get smaller projects, and I love them because they allow us to experiment. This particular one was with in collaboration with a nonprofit that focuses on water, um, um, focuses on the proper use of water. And what this project allowed us was to make a device, an experiment of using generative sound design, these water sounds, that connect with the Kinect sensor that we were using. So in a way, we had this amazing developer, Guillaume, making the visual side of it. And we use it as a way to not audio reactive, but the other way around, like to have audio reacting to this shared texture of this sensor that we were using. But of course, not everything is high tech. We also collaborate with amazing musicians and amazing artists. The audio team is also in charge of making the content, producing the music and the sound design. So this is uh, a little recording session with an amazing Mexican percussionist, Diego Espinosa. This is a big part, like this collaboration size was part of the magic, right? So part of our philosophy is that all the technical stuff, all the high-tech stuff has to follow content, has to follow the heart of the music or the ideas behind it, right? Another example, we try to develop in-house some pre-visualization systems. And for this, we try to get our hands into 3D technology. We as audio people, like we work with our regular production tools and whatnot. And thanks to collaborating with our friends in technology, in the area of technology within Cocolab, we were able to make this pre-visualization software that allowed us to move in a interactive way through a 3D space and be able to sync our production sessions with the visual content because we needed context. That is the main idea. We needed context in time through the story. We needed context in the spaces, like because this is not a single screen, right? So we need to be able to sync stuff with the different uh, spatial side of the visual elements. And I'm gonna go a little bit faster because I want to go into the Q&A with my friends here. And another example of like this do-it-yourself idea, we also spend a good amount of time working on our own playback system. We use MaximSP as a main platform, and the idea is to be able to sync the audio parts with all the other systems. That was one of the main concerns. And the other was to be able to scale, once again, be able to play back whatever amount of tracks and be able to very quickly route it to whatever system we have in our hands. This is a little bit of a later version of it. We try to strip it down for whatever the project needs, right? So this one, we talk about it as an audio backend. So the idea is that we use it when we are integrating, when we are on site, finishing the mix, we are uploading our music stems or music files. We route it to 20, 30 audio channels, whatever. And then we let this tool communicate with show control systems. So we have a network of messages. We have a synchronization SMPTE audio file flowing around. And the idea was to facilitate our workflow as music people, and be able to connect with the other systems that needed integration, right? So this was developed in-house. We used MaxMSP. We shared. We use these shared protocols as MIDI, OSC messages with the other systems, and that's how we integrate audio with all the other systems that are going on in the different in our different projects, right? So just to recap a little bit, we are using technologies to diminish certain limitations, both during the production part of the project, during the design part, and of course during the integration and operation side of these projects. So we use software platforms that like MaxMSP. We're using 3D tools and game engines like Unreal Engine, and that's some of the ideas about like these technology tools, right? And on the other side, we have these constraints that we put on the creative process. Like we like to think about our process as artisanal, a little bit of DIY in the tech side. We rely a lot on collaboration with musicians and composers and artists, and we also think a lot about the processes, right? Like the concept and design phases. How I'm sorry. How are we going to develop something that is reliable to stay on site like for months and months and so on, right? And this is just another example of the finished product in the night experience in Schmal. And I always like to finish with this picture because this is us like early in the morning after running around in the jungle and getting bit by mosquitoes and whatnot. But this is the time and place where we feel like we made a good job, right? Like we are honoring the culture, we are honoring the craft, and uh, and that's it actually, right? Okay, so thank you very much for listening. I'm gonna.
That's fantastic. Thank you, Martin. I love that term ear people. I've never heard that before.
Yeah,
Exciting
yeah. We're
projects.
yeah. We love to joke around. We have eye people, the animators. We
Yeah.
are the ear people. We have the people, H,
Yeah.
human
Very
resources.
important. Very important.
Yeah.
So we have some space to have that conversation in the end. I'm going to jump into introducing our next speaker. So our next speaker is a video game composer and a sound designer at Dynamic Media Triad. Outside of video games, his work explores probability and complex adaptive systems within the context of music. Please give it up for Raul Feliz.
Hi, am I coming clear there? Am I not too loud? All good? Great. Let me share my screen real quick, just so I can set it up and start. Okay. A couple of slides, but I will be, let me know if you can see, you should be able to see like kind of my whole screen. Is that coming through? Okay,
Yep.
Great. All right, well, thank you. Thank you, Kako, for inviting me. Thank you, Martin, for your talk. That was really inspiring. That's quite amazing. All the stuff you guys do. Really is an honor to share this talk with you. When Kako told me about this talk, I kind of was like, oh man, what am I going to talk about? There's so many, and not because of any lack of things, just because of the opposite. There's so many exciting things that are going on right now with sound, with technology, with music. A little bit of my background real quick before I jump into this is I'm a trained musician, a jazz musician by like professional training, but it really, my like interest in composition have kind of like pushed me towards asking questions that I think technology can aid me in discovering. Like my whole thing with technology is allowing it to put me in situations that are unfamiliar to me. Like sometimes I will feel like I just want to play the piano that day and I will play piano acoustically and I don't care. And sometimes I want my computer to really just spit something at me that I struggle to understand but is inspiring. And in the quest of this, in the quest of like pursuing this inspiration or this like extra going this into this extraterrestrial domain or kind of transcendent domain, I really like Martin's comment on kind of like do yourself, do your own tools. I'm a believer of that. I'm also a software developer as a video game composer. I author sound engines for like and plugins for game engines, as well as audio processing, DSP, digital signal processing. Today, I thought I'd do something a little bit different. I'm going to describe a particular method that I've been having a lot of fun with in terms of making music using reinforcement learning, which is a kind of machine learning type of AI. I will, if everything goes well and technology doesn't fail us, I will be training a small neural network during this demo to produce a little beat music thing. But okay, let's see. Let's start a little bit. I just to call this behavioral music making because it's the goal in this system for me. It's to come up with these structures that generate music, but not in a kind of pre-programmed way, but kind of like I like to think of them as organisms that have a little bit of an evolution, and then they learn to behave a certain way. And then I let them loose into a game or a system, and they do their thing. They react to the environment. They behave. They have a behavior, right? Behavioral-based composition, I'm going to use this just quick definition here. It's like, as I said, a technique in which the elements of the composition are generated or altered by some time-dependent decision procedure. And I really want to put an emphasis on that word. We'll come back to it later. Associated with an agent, right? Like this is the behavior of the agent. This has a lot of applications, obviously, in interactive systems like video games, applications in general, software, art installations, like Martin was showing us some of that wonderful Frida Kahlo stuff, where you want sound to be dynamic and necessarily, you know, maybe you don't want to record 3 hours of music. Maybe you can record little fragments and they can be mosaicked or collaged differently by people accessing the environment, and then from small material you can extract a lot of runtime. We do this in video games all the time. More importantly, I believe that this kind of approach allows me a sort of scrying, and if people don't know what that word, I didn't know what that word was until recently. So it's when you look into like a crystal ball, or you read tea leaves, or you go into you see the stars, the night sky. This activity of finding meaning or discerning messages through noise and signals and patterns is called scrying, and it's an integral part of human culture, right? To me, as I mentioned at the beginning, computers can give you can be a mirror to yourself. Like recording systems can like kind of remix you or suggest new things to you, and finding this way of scrying and chasing inspiration is kind of what I'm trying to do with this. In order to do this, one of the most basic systems that we do is called a Markov chain. People don't know that. It's basically this is not that great a diagram, but imagine out of all these dots represent states, a possible state a system can be in. And then all of the links represent transitions to other states. The links here can represent like the probability to going from where I am now to where I want to where I'm going next. I'm going to show a little live demo. This is a Markov chain app that I made to author music. So before I play it, I'm gonna make sure. Can you hear this? Cool. You should have heard a little boom, boom, boom. So the way this works is I can make a new node. I'm going to say it's MIDI node 60, which represents middle C for musicians out there. I'm going to make another one. I'm going to make a C major chord, right? So the next one would be 64, which is E, and then 67, which is G. So these three notes, I'm going to say start here and then go here and then go here and then go here. So it's a little loop. So if I'm going to go first here, then here, then here. I'm going to start a walk, right? I can make it so that instead of going back always like that, there's a chance that I can kind of like go back from here. And I'm going to actually increment the probability of that happening just to show it. I can, once the behavior is going, I can change the rhythm of this, right? I can kind of like, right now. So yeah, this is, again, eventually I'm going to make a whole user interface that's more friendly. Like right now it's a little, since I am the only user of this, it's similar to Martin, you know, this is the life of the engineer. You make these tools for yourself, and then when you have to show them, you're like, oh, well, it works this way. I pre-made a little network that goes through a lot of states. In the final version of this, of course, I want nodes to light up when you see notes being played. So in your mind, I want you to imagine, as you hear these things, notes kind of lining up, and through the links, you know, when you see those animations of like neurons and brain synapses like firing, I want you to imagine that's kind of going on. So I'm going to play this one a little bit, see what kind of behavior, and again, think about behavior this has. As we listen to this, we notice that there is repetition because the probabilities are set up in a way that some events are more likely than others, but some events are very rare, but can happen. We will listen to, for example, this vertical column is rare that it happens. We have to, you heard it there. That is a strange case, but can happen sometimes. I can have in this application another Markov chain happening at the same time, this lower one that's kind of long, elongated. I will play it on its own for a second. This is more of a loop. So a Markov chain can also represent a loop, a completely deterministic loop. This has no other pathways. It can't go anywhere else. It'll always play this. And I can have them play in conjunction. Okay, so that's a little demo of what a Markov chain is. That's not what I'm going to be talking about, though, even though it's cool. The idea is that these things, like, you know, I can sit there and design it and make it, and it's a lot of fun to sit there and make these systems and go like, oh, maybe if it goes here, it can go into a whole other section where it changes key, and then it comes back, and you can design these systems, and it's great. But there's many ways to converge to this, and I made some slides explaining a little bit of the mathematical underpinning of this. I might skip them due to time, but I want us to think about, again, that word that I said, decision procedures. If we think about it, a Markov chain is a decision procedure. Given a given state, I have some options of where to go, and I have probabilities. Maybe more likely I'm going to go somewhere versus the other place, or maybe equal probability. Decision procedures, mathematically, when we can think about them in the most general form, we can think about them as maps, which is my favorite concept in all of math, because a map is everything in mathematics can be understood as a map. And for now, for the purposes of this conversation, let's just think about a map as what you see on screen, kind of like you have a set, in this case A, and another set of things B, and it doesn't matter what the set of things is. Could be numbers, could be apples, could be notes, whatever. And for each of the numbers, you can have another number in the other set, right? This is a function. Maps are everywhere, right? And in this case, so I can give a little bit of nomenclature as well. The map where the original set that is being mapped on another one is called the domain. The domain that is being mapped on is called the codomain. And the region of the codomain that has all of the points that are being mapped on is called the image of the function or of the map, right? And don't worry too much about it. It's just so I can kind of talk about what's coming next. I will skip these examples of maps because they're not that relevant right now. So the idea is to, again, design these behavior systems. I could sit there and make them as I was doing, and it's fun. But I thought, you know, there's this thing called machine learning where you can kind of feed data to a system and have the system converge to a particular desired effect. Now, obviously, people are now very excited with stable diffusion image generation, for example. People have seen those wonderful images that get generated, or ChatGPT. These are maps. Again, every neural network, if you're going to take something out of this talk, is remember this: every neural network, every artificial intelligence process is a mathematical function. It's a map from a set of inputs to a set of outputs. In the case of ChatGPT, you might have like a paragraph that's a context, that's the input, and then the output of the mapping is the next word that's predicted. And you can think of it as a Markov chain, just a very big one, just huge, huge, huge. That is modeling statistically the probability of going from one stage to the other. In this case, we'll do a little toy example. Reinforcement learning works like you would teach a kid if you were being impatient. You'd be like, hey, kid, do this thing, and if you don't do it, I'm gonna, I don't know, slap your wrist. Don't hit kids, but I don't know, I'm gonna yell at you. And if you do it, I'm gonna give you candy. Positive and negative reinforcement, right? The mechanisms that mathematically where this happens are a little sophisticated, so I won't go into this right now, although they're very beautiful. So right now we'll make a little drum machine that learns to play the drums from nothing, from not knowing. So in other words, it learns to create a Markov chain that plays what we want without us designing it. We're just going to give it a policy. So we'll have an agent. In this case, it'll be a Python script that will have 3 actions to take. Let's call it action 1, action 2, action 3. Could be anything. Could be play a kick drum, play a snare, play a hi-hat, play a given note, whatever. In this case, state 1, state 2, state 3, and state 4 represent a beat in a 4 count, like 1, 2, 3, 4, 1, 2, 3, 4. And we have a policy. We will design the policy. Instead of designing the Markov chain directly, we will design a policy, meaning a regimented scheme of punishments and rewards. For S1, we wanted to, in this example, play action 1. For S2, we wanted to play action 3. This is very abstract, but bear with me because I will jump into code in a second. I think these visuals will help. So let's say that agent 1's like, okay, I know my policy, but right now I just have a random brain. So I just see state 1, and I'm gonna choose action 1 just randomly. Oh, well, that actually was what I wanted, so I'll give you a reward. So that's great. And then I'll move to state 2. The agent has been, okay, cool. State 2, I don't know, action 1 again. Sorry, that's not the case. This process will be continued iteratively. Obviously, in AI, we do this millions of times in order to kind of hammer out the brain of the agent. And we want it to converge to a certain behavior. Let's jump into code real quick. This is a system also I've made. I apologize for showing you all the guts of the system. I haven't made an interface for this, but a lot of the cool things happening this stage, you know, when you're coding and it's plasma and it's changing and it's broken, but you're also like, I feel like that's the point where artistry, as like me as a musician and as a programmer, meet at this point of creating the code. So I will try to have an agent. I will show you how the agent, before it trains, how it sounds like. I'm going to have it control a drum machine. Let me know if you can hear that. It's pretty erratic. There's no sense of rhythm. It doesn't know anything. If we were to visualize the Markov chain of it, it would just seem like every action is connected to every other action with equal probability. So there's no structure. You can see here, this is a very rudimentary like logging. Don't worry too much. I'll just speak about the colors. The more green that you see, the better it's doing. That's a sign that it's getting what I want it to do. Right now, it has no systematic way of getting it. And the red is when it does something wrong. And when it's black, it's neutral, right? So again, system is dumb right now. It doesn't know anything. I'm going to train it as a means of demonstration to play only kick drums. 1 second. So while it's training, I can see right again the rudimentary. Right now, all I can see is the gradient of the training, and once I start to see that it's positive, it means it's getting a lot of good rewards. If this works well, and hopefully, fingers crossed, because you never know with stochastic processes, we should have a drum machine that was given candy every time you play the kick and nothing ever else. So it just learns to play the kick always, every time it sees a new beat. And now, yeah, I think let's stop it. say, let's stop it. Oh, well, it doesn't want to stop. Come on. There. And as we predicted, it learned to just do that because that was the incentive we gave it, right? So let's do something more interesting now. I'm going to design a policy in order to converge to a behavior that's not as like redundant. Right now, we just kind of told it to repeat forever. That's your goal in life. And no one just wants to do that, right? We want to be creative. So I'm going to tell it, I'm going to try to get it to play its traditional drum group, like a. I'm going to be, as a demonstration, I'm going to be like, I'm being very verbose with my description here. I'm being, if the first beat is, if you don't play a kick on the first beat, then you get a negative reward. If it's bit 3 and you don't play the snare, so I'm really going to spell it out. And the reason why I'm doing this in such a toy example is because training AI, I don't know the knowledge or experience that people have in the audience training AIs, but it can take a lot of time depending on the dimensionality of the space. Right now, I'm giving the agent only 8 beats to look at, but I could be making it look at its own history. I could be making it look at so much more. I could be giving it more options to play. The map between the history and where to go can be as complex as we want it to be. So right now we see that the gradient is still negative sometimes. I'm going to wait a little bit until we get to some interesting behavior. What we'll converge to will be a Markov chain. We won't see it, but I want you to imagine where every time the agent sees a beat, it has a map of probabilities of where to go. And every time it goes to a new place, there's new probabilities. So it's not static, it changes too. And since the probabilities are not like a hard decision, it maybe has, it can make errors, and those errors are good because, it's a heuristic. It's like a messy, inexact decision procedure. And that's the kind of behavioral composition that I'm trying to demonstrate in this process. Let's see where it's at right now. Okay. Stop, please. Please stop. There it is. And right, so same system. You didn't see me change anything. All I changed was the carrots and sticks. And so, okay, you might be like, all right, well, I could have just written that on a drum machine. Like, why do this? Let me just play with it for a second. Because talking about this cry thing, right? Like, I hear this beat, and maybe I just want to, So again, it's already, even just hearing it, it's kind of inspired me. I could have recorded that, right? I could have recorded that just happened and go. But then I can also be like, hey, I'm not going to spell it out for you. I'm going to give you very general guidelines. And then just sparse rewards. And then so you'll converge to a very different behavior that gets some rewards sometimes. And this will be the last one I do. But it won't be every time I train, it will be different, right? Every new one will converge to a different behavior because the rewards are so general. So all I'm going to tell it is don't repeat yourself and play kicks and snares at the time that you have them right now. And if you play with constant rhythm, you get a reward too. So let's see. Let's let that run for a second. How am I doing on time? Still have a little bit of this is the last one I do. Cool. The whole thing, again, I will say, is this is a discovery procedure. Not only it's a capacity to create generative models, but it is a discovery procedure for me, the artist, right? I can train it to generate melodies. I can train it to react to chords that I play. I can train it by giving it a policy. And by phrasing music composition as a game, I can teach an AI to become really good at that game, right? Or to exploit strategies that I don't even know. And it helps me discover things. And this is the kind of stuff that I love doing with AI. And I really encourage people, artists, when they think about using AI, it's nice to use other people's AI stuff. I mean, obviously ChatGPT and noise diffusion is incredible what you can do. But if people are curious about AI deeply, I would say jump in and learn to train your own models, because it's a lot of fun. And then you start seeing that like AI itself is a whole field where like your authoring of algorithms is in itself it's on its own a creative endeavor. So now we have, let's listen to this behavior for a second. I'm going to show you, so this is my logic session. Since I'm sending everything as a MIDI file, I can record it. And you can see here, wait, that's the MIDI data being generated by Python arriving. You can see it. As you can see, the different colors are different velocities. I'm generating also different loudnesses. This is a drum machine that learned to play in its own groove. If I train it again, it'll convert to something completely different. But it'll still be rhythmic because I gave it those general rules. And it's kind of like when you know, let me turn it up. It's kind of like when you teach artists. It's like you don't want them to fully obey. You want them to make it their own. You want to evolve their own kind of behavior. Okay, and just if people are curious, this is just kind of like what's happening. Just if people are curious, I have a Python script generating this three-dimensional points, right? MIDI tuples that have a MIDI number, which is the pitch, a velocity, which is the loudness, and a duration in seconds, right? I have the Python script does all the neural network training, and then from that it generates that. I send that to an internal virtual MIDI bus that then Logic or any DAW listens to. The reason why I separate all of this is because I can then generate, like you saw me generate that drum machine. What if I want to change the drum sound? What if I want to change the kick sound, right? So like this separation allows me to plug and play the different parts, and thus it's very creative. So just to recap, Python generates this token. This token is sent to the virtual MIDI bus, and Logic listens to it and assigns it, again, another mapping to an instrument. I think that's all.
That was fantastic, Raul. Keep that last slide up. I think it segues nicely into conversation because you got us all scrying over here. You and Martin got us all scrying. Yeah, I mean, I'm gonna step out the way. I'm curious what Martin has to say about your work, Raul, and what Raul has to say about Martin's work. I think this conversation is gonna be interesting. So I'm just stepping out the way and letting y'all take.
Cool.
Hey, thank you very much, Raul. That was amazing.
Thank you. Same, likewise. I really, I've seen the immersive free stuff before. I didn't know you were involved with that. It's really cool. Yeah.
Oh well. No. Yeah. Thank you. I was just one of a big team of amazing people, and I was like, out of my.
It seems like a very, very, very complex system, right? So many moving parts, so many connections.
Yeah. It needs some neural networks to be optimized.
Yeah. That's exactly like the whole thing with neural networks. I feel like we can use neural networks to optimize things, to fix things, but we can also train them to create randomness, to create random signals. So it's really cool.
I actually had a little question because it was just like Kako said, I was scrying a lot about it. And you mentioned this idea of convergence, right? Like when one of your models, after you train it, it converges. And I was really wondering, in your experience, do you think the convergence objectives of these musical systems are maybe similar, or they're very distinct or very different for maybe systems built for text or systems built for images?
Mm.
Do you find similarities? Do you find
Yeah.
very clear differences?
I think, yeah, I mean, I think every domain, be it audio, visuals, has their own quirks, right? Like, because I like to think of the convergence of an algorithm, of a neural network, as a search algorithm. Like, in a way, what's happening is that the neural network is it's iterating through a guided manner through a lot of its parameters and changing them to find the strategy that optimizes. Some environments are easier to solve than others. Some environments have more dimensions. Some environments have different non-linear pathways to it. And this affects the architecture of the model and also the time it takes to converge. I think, for example, like audio, generating raw, if I was generating, right now I'm generating a sequence of tokens, right? But if I was generating raw audio bit by bit, that's a really big sample space. Like, that's why we don't really yet have amazing, incredible music, generative music, raw audio yet. It's not that we don't have, I think the model, to answer your question, it's really the same problem, but the difficulties of each individual one are more in like how hard it is to search that space of possibilities. Obviously, by limiting here in this demo to only 4 actions, I was able to train a neural network live. Like, normally you leave these things overnight through a GPU, right? But I made a toy example. But yes, I think that's they are the same, but they're different. If that makes sense.
Sure.
Yeah.
Yeah.
Yeah. I was gonna ask, do you guys at your studio, are you guys doing any AI or any neural network stuff as well?
I've been involved in a few research quests, right? And some of them are about learning how to synthesize voices, right? Like training a model on a particular timbre or a particular person's speech, particularities and stuff. And it's not yet come to a conclusion. That's those projects. We're researching and we're looking what's out there.
It's an exciting time for that, I feel like, right? Because everyone is trying different things. It's cool.
Yeah. In that regard, I would say that the access to the tools, like the access to being able to train your model on a Google server or whatever, like that's so much. Once you have this know-how and you're interested and you spend a little time learning about it, the tools are there.
Yeah. Cloud computing allows you to do it really quickly. Yeah.
Yes.
If you can, I think the skill for the artist, and what I would like to think about, like the artist in the cyber AI era, is to understand how the principles are basic, are simple. You don't need to know all the math. Like, you can if you want, but the principles are basic. And then just knowing this, you can start training your models, creating your own little brains, systems of brains. And I see a future where artists see AI models the way some artists maybe might see a paintbrush. It's like, it's not necessarily that the goal of the AI is to replicate and to copy or to replace. The AI is just another way of generating, another way of scrying. So that's cool. That's true. The tools are there. I really encourage young artists, particularly people in this program who are watching, like to I know sometimes it can sound scary. You see all the math and all the things, but it just a little bit of patience, and you're already there, and you can apply to anything, because the problem, a neural network is data agnostic. It just knows that it's like for processing data, and then you map the result to whatever you want.
Right.
Yeah.
You mentioned a couple of times, and you just said this word that resonates with me a lot. You mentioned this idea of maps or mapping. And I think it's a coincidence, but I've been like really thinking about this idea, not from the map perspective like you presented, but from a like navigation aspect, like using the idea of a map to like move around, right?
Yeah.
And I think it's funny how the coincidence work, like
that's true.
we all are going to have to navigate these tools, right? In a way, like use them to go forward, like to have a creative process, like to arrive to conclusions. And I agree. I think it's going to be like crazy how important it's going to be now and in the future, right?
And the process itself has many quirks that are kind of unique. Like I didn't do it in this demo, but sometimes I will let the thing, I will hear it as it trains. And it goes through these weird moments, weird behaviors, erratic behaviors before it starts to learn the dominant strategy. It tries all these fringe behaviors. And then sometimes I'm like, stop learning. that you're doing right there, keep that.
It converges into something interesting, right?
Yes, exactly.
Awesome.
Yeah. Thank you for those questions. That's wonderful.
As a jazz player, as a jazz musician, do you find yourself like using these tools to explore styles, like not like data dimension per se, but like exploring styles and stuff like that?
Yes, yeah, of course. Like that's
Cool.
that's the whole thing, right? Because as a jazz musician, we kind of prioritize improvisation and music that is composed in the time that it takes to play, right? Like that's kind of how I would define jazz. Like, and it's this process of like playing and reacting to what you played, anticipating, maybe tweaking a little bit and kind of going, and I see these systems that I make. This was a simple one as kind of an extension of that. So it guides my design principles as a programmer. My musicianship, enters that way here. But yeah, there's infinite ways to create generative systems. Hopefully we'll have some other chances too in the future to share more. I want to know more what you're doing. I have many things that I make too that I would love to show here. This is really great.
Awesome. Yeah. I feel that way too.
Wonderful.
I'm a bass. Kako, do you wanna?
Well, I'm not an ear person, but I've got two ear people here, and I'm curious. Both of y'all touched on the demands of music now from different perspectives, and I'm curious what that means. And when you're creating these systems, do y'all feel like you're inventing instruments? Like, what does that feel like? Like, is this? It's like it's a new violin that only you can play or something like that.
Yeah, in a way, a little bit, yeah. I feel like it's well. Sorry, go ahead.
No, you first, please.
All I was gonna say is like it depends. Like, for example, in your presentation, I saw that you have a vision, like you want to achieve this, and then let's make a tool that helps us get there. And in that sense, it's kind of like the engineering fact. I think that's great. And it's like the invention of the tool is within the context of that. And also, I guess in my case too, it's like I want to create quirky behavior things. But it's engineering can also be open-ended like that, where there's like no real, end to it. You just kind of want to connect things around. Like people who play modular synths do this all the time, right? They create these feedback loops with electronics just to create chaotic electricity motion, and they send that to synthesizers. And this idea of creating the instrument for the concert or for the performance or for the system, and then moving on and creating a new instrument is a kind of artistry that I really enjoy.
Yeah. I think Raul can really relate to the idea of bugs. And when you're programming and a bug arises, right?
Yeah.
So when a software engineer is developing, we come across bugs all the time, no? And for me, I mean, it's a problem you have to solve, right? But for me, it's a moment of pause, like going like, all right, this is a device on its own, right? It's just, I'm working on it, and I'm trying to go to an objective or solve a problem. But whenever I see this idea of the bug, I always remind myself that, okay, this is a device on its own, right? This is like sort of like an item on its own, right?
Right.
So I have to have a relationship with it. It's not necessarily that I have to squash the bug, and
Correct.
I have to work with it, right?
Have
So
to work with it, yeah.
yeah. So
Yeah, especially
in
as
a
they
way, it
get
reminds
bigger.
me. Oh, sorry. In a way, it reminds me of like I am a bass player. I used to play the bass. In a way, it reminded me of like, okay, yeah, you have to have a relationship with this device, not just work to dominate it. Like it's a little bit of a relationship. So
it's true. It's
very
true.
interesting in AI how that takes a different level or creativity and stuff.
Yeah, correct. Yeah, it's very exciting. Yeah, I really wish I would have. I'm sure we'll have some other opportunities because like I said, I told you I make video games, right? And I make the sound for different, and I really try, particularly in the games that I'm working on right now. We try to make. Sometimes you want a piece of music that's pre-recorded and scored for that moment, but sometimes you want the control of the player to determine the music, right? And you can be very granular or very broad strokes with that. You can say the player exists in world space as three points, X, Y, Z. That is 3 control signals that I have to send to whatever I want. I can have those change the weights of a Markov chain. I can have those tweak the pitch directly. The map can be direct or indirect, and you can just have a lot of fun. It's almost like you're building in the instrument, and then when the player plays the game, they play the music, right? It's kind of like, and you try to cater the design towards the gameplay loop. In that sense, you work with the game designers as well. They're like, look, I want the player to do this kind of action, and when they see this, to react that way. And I imagine, I wanted to ask you with the Frida like that, it's kind of like that, really. You want to get people to navigate or work a certain way, to stop at certain points, to pay attention to, and it's all kind of working together.
Yeah. No, that's a amazing point. We had to leave the record mentality and think about the 3-dimensional aspect of it, right? Like, where are people gonna go, where their attention is gonna be pointed at, and it's definitely we had to design on those principles actually, and it was interesting. It was amazing to think about that. More so in the Uxmal project, because you have to walk through a lot of different spaces with new rules as you walk through them. And we had to design music for those new rules, like walking from point A to point B. Definitely, it was a game changer to have that switch in your head.
For sure. Anyone that hasn't tried but is curious about nonlinear music, really recommend it. It is as you said, it's switch in your mind is like, I didn't know this was possible. I think of composition completely different now. There's no beginning, there's no ending. It's just kind of like a flow, and you just guide the flow. Yeah.
I wish this conversation could keep going on forever. We're gonna have to like get you all connected. But there's some good questions coming in. I want to leave some time for people from the audience if they have any questions. So I'm just going to read one out from Jake Silvers. Would an advanced music AI know how to play good music based off of balancing repetition and coherence? If so, do you have any comments on how that might be possible?
Yeah, that's a good question. I think, for example, you thank you for the question, and you are kind of already thinking this way. It's like you realize that a general principle is repetition and maybe newness, so you can kind of design a policy that says do these things, but as you'll find, there's when you start doing these things, the AIs will find other ways to maximize their rewards that you did not expect. And again, that's part of the fun, as we were talking. So you got to learn to accept that. The concept of good music, that's where the scrying comes in. That's why I feel like AI doesn't really replace people, because the AI outputs things, and then you listening to it, interpret if it's meaningful or not, and then maybe tweak the bot to convert to something different. Or you take certain snapshots of what it takes, really record it, and then show that. In that process of curation, the synthesis between the chaos of creative flow that the AI generates and your curation is where like good music is born in that sense. But yes, you're already starting to think that way, where it's like, I have general principles that can be enforced loosely. And then the AI can fill in the gaps in between.
I just want to Thanks for that, Raul. I just want to make sure that the audience knows we're opening up the floor to questions. If anyone has any questions, just please post them in the chat, and I'll dictate them to the speakers now. So, Martin, do you have any thoughts on this as well?
Well, I love that you're framing it as collaboration, right? You in a way are collaborating with your model.
Exactly.
See, I would think that that's a very creative, very interesting way of exploring this tool. Like collaboration and exploration of the possibilities. Again, going back to that idea of this thing that is outside of you, and you have to have a dialogue with it in a way, right?
Yeah. I think also in the general, I feel like the question also seems to hint at a more general philosophical principle on what makes good music or good art or whatever. If the question is, can good music be reduced to a formulaic expression and then trained? I don't necessarily think that is true. Not necessarily because music has an intangible capacity of what makes it good or bad, but because that is always a changing thing, right? Like if I know that it was generated by an AI, that already is coloring my perception of if it's good or not. Even if it sounds perfectly like I see some AI generated like photos right now that look incredible, but because I know they're AI, I'm like, it's AI. So the idea of something being good or bad seems to transcend under what rules it was made, right? If it was a computer or a person or whatever.
If there's a person at the end still deciding that, right?
Yeah.
There's a ethical dimension to it, right? In
Absolutely.
a way.
Yeah.
Even in art, right? Well,
yeah.
So we've got another question from Lydia. Martin, why use the term ear people instead of solely referring to yourself as a sound designer or engineer? I imagine there's a deeper meaning to that in a way, and I appreciate that.
Thank you so much. Thank you so much for the question, Lydia. The idea is that our group, our little group, or this little sphere within this bigger sphere, this bigger group of people, is that the ear people can approach problem solving through music, through sound design, through making decisions about acoustics, about intention, about art, and we also are goofballs. Like we like to joke around all the time. So the term ear people was a little funny in a way, but the idea was to use our ears to solve problems. That was actually like the whole point of it, right? So when we were developing and designing, we talk about the music side of the experience as the heart of the experience, right? We want to bring emotions to the table. There's some of our objectives with composing, in recording artists, with finding ways to play back in a different setting, and that's about it. It's a little bit of a inside joke, but it comes from that idea of using our ears to solve problems.
That's fantastic. So I just want to give y'all like a big round of applause. Thank you for the presentation and the conversation. Really insightful. I want to give you the opportunity if people want to see more of your work, what you're up to, where can they find you online?
Oh, thank you, Raul. I go on Instagram every once in a while. I don't have much of online presence there, but I always happy to receive direct messages and talk about these projects and whatever I can be useful for. I started a little Telegram group for Maximus P. Is for Spanish speaking users. So it's small right now, but we have people from Peru, we have people from Argentina, we have people from Cuba, from people from Mexico, obviously. So in the past weeks, I've been a little silent on that as well, but I love to see people interested in, especially I use Macs a lot, so that's where I find myself sharing projects, sharing know-how and whatnot. So that's a good avenue also, even if you're not that interested in Macs, but you want to hang out with people that uses this kind of tools, you're more than welcome. So I will. You can find me as Martin Rivera in there in Instagram. I'm sorry, I have a little bit of a weird username, but I'm sure you can find me, and we'll find ways. Thank you for, thanks to Kako and thanks to Woodbury University. That there'll be links to all those platforms. Please go ahead.
Nice. Yeah, likewise. I'm not a very active person online, but the company, the studio that I make games with, does have a presence. So it's Dynamic Media Triad. We have a Discord server. We have Twitter, Instagram. Website. You can find us, and there'll be links. I'm currently scoring 2 games for them. I've scored already 3, and I have no plan on stopping. We are a small team. So we're not like a big studio, right? We're a small team, very passionate. We're all from Mexico as well. And our games are like creativity first. And since we're small, it's usually easy to catch us there. And in our Discord, would be the place that I would recommend people to check out, because there's like fans of our games talking about it. They're sharing fan art or like questions, and you can find me there.
Oh, sorry. I just would like to also thanks to Coco Lab and all the beautiful projects that we made together. So you can find Coco Lab International in Instagram and the other platforms as well.
Fantastic. Well, thanks again, Martin and Raul, for this this conversation. I think you've given us a lot to think about and a lot to get excited about. So looking forward to seeing what cool stuff y'all do in the future. All right, so I guess that's it. The first inaugural lecture for the series. Woo! Thanks, y'all. Definitely made it special. I didn't know how this platform or how this framework would work, but I really enjoyed the conversations that y'all had. I'm gonna be a fly in the wall next time y'all start talking about music. But that's it. So that's it for episode 1, I guess. So have a great rest of your evening, and we'll see you back next week.
All right.
Thank you very much.
Bye.
Bye.